everyone. So I wanted to take you through an activity that I made when we were just starting our unit on maximum and minimum values, and this was in my calculus class. And so students were learning the difference between local maxes and mins and absolute maxes and mins, and also exploring critical numbers for the first time. So on this question, just a really simple one to get them started, drag the red dot to the absolute maximum and drag the green dot to the absolute minimum. So most everybody got that one correct. And then on this one, so this question asks, place a red dot on the critical values. So we had just talked about critical values in a more algebraic sense. And so this activity was all about kind of getting them to see the connection between the algebraic stuff and the graphical stuff. And so here in this specific slide, you can see that they didn't really understand graphically what critical values meant yet. So here, what is the absolute maximum value? So they had to type in the answer there. You can see that some students are still forgetting that when I asked for absolute maximum value, I need a y coordinate. So that was what that was all about. Same thing for absolute minimum value, except they're catching on now. And so from here, what we did was we took all of the graphical things we were learning, and then on the board, we were doing everything algebraically with the actual equation and finding the actual numbers algebraically, and then we were matching it up with all the graphical stuff. And this is just one more Pear Deck that I'm going to go into. So how I usually use Pear Deck actually is my students all have little tablets that they plug into their laptops, and so they use that to use the drawing feature, and they can actually write on their screen. So in this question, I asked them to actually evaluate the limit, and so you can see here that they can write really, really nicely on this, and because we do this so often, they're getting pretty good at writing on the tablets. It was a little bit difficult at first. So usually I just project the question, they solve it, and then I show all the responses, and I look for a really nice one done by the student, and we kind of just talk that over as a class, and so it kind of remains anonymous, but we can talk about the student's work as opposed to me just writing the answer on the board, and it's much, much quicker than having a student come up to the board, so I love that. This was just a multiple choice type question. Then again, in this problem, they did a bunch of work and they were able to write so much on the slide, so I've been really happy with that. You know, this is so great for shading. Given the graph, go ahead and shade where f prime is greater than 0, and I love using the overlay for that to see if the whole class matched up, which they did on that one. On this one, some people were happy. Concave up, I always say, is a happy function, so that's why they did the smiley face. And so I'll just keep going through these slides, but this was actually just our exam review, and so we did the exam review through this instead of kids writing on paper, and it was really nice. And so while this is not any like phenomenal lesson here or anything totally out of the ordinary, it just made it really nice from both my view, the teacher view, from the student view, and it was a way that the students could be kind of presenting their answer in front of the class without having to move back and forth throughout the class. So it actually saved me a lot of time. And I know that one of the questions we were talking about was, does Pear Deck take you longer than it would have taken in a traditional setting? Well, yeah, setting up the Pear Deck does take me a little bit longer a lot of times, but then I have the ability to have students presenting their answers to each question without them having to move up and back from the board and to the board. So I think all in all, it ends up saving me time after I've done that initial work. So yeah, hope you enjoyed.